quality, but when you make it an animated GIF, it gets 270% larger. And that's kind of the wrong way if we're thinking about performance. And so why are animated GIFs bigger? GIFs are actually sort of a slideshow. And so there's 35 images that sort of just flip through, like when we were kids, we would do stick figure books and they flip through. Do people still do that? I did that when I was a kid. But there are all these pictures, and video compresses through the third dimension of time in addition to X and Y, so that's why the video file is so much smaller. So, what happens if I make this an MP4 and cut it down to 256 colors, because that's what people love about animated GIFs, is that they're 256 colors and they kind of look like crap. And so if I do that, you know, it's the same thing. I also stripped out the audio, because on an animated GIF, there's no audio. And it's 250 kilobytes, which obviously is a way, way smaller. And now I can put that onto my website with a tag like this: autoplay, loop, muted, controls, so that I can't pause it, right? And then I just load the image. And on mobile, on the web, autoplay isn't enough. You have to do autoplay and muted. And the reason for that, that's in Chrome and Safari on mobile. A video will not autoplay unless you use both autoplay and muted, so that when you're in class and you open a web page, it doesn't start blasting whatever movie is on the web page. But the problem is video tags are slow. The tags load, the space is allocated on the web page, but it doesn't load the video. That's the last thing that gets downloaded. So that means this approach, the file's a lot smaller, but it may actually be slower to show up on the screen than that giant 3 megabyte animated GIF. Now, coming out, and there's a blog post about this in one of the Safari previews, and this is in the Safari preview right now, is you can put videos inside the image tags. And they'll autoplay and they'll loop. So you can now put, you know, an animated GIF of cats. And so here's, you know, you can do it as a WebP if you want, because WebPs can also be animated and they're smaller than GIFs. You can use an MP4, and it will autoplay, and it loads fast because the image tag takes precedent. It's one of the first ones to load. Now you have to use this really, really wisely, because if you use a small looping image of a goat, it will loop that goat. But if you put like a 2-hour-long movie right there, it's going to download and play the entire movie in that little tiny bit on the screen. So you need to make sure that you're using the power to use video tags in the picture element properly. But if you're interested, there's a blog post, and it's kind of a new, exciting thing that might help deliver animated GIFs faster to customers. And then you can do things like make sure that when actually you want to download it, it comes down as a GIF, so you can put it up on Twitter or in Facebook or whatever you want to do with it. And then finally, we're going to hop right into video, because as we all know, video is just growing like crazy. It's huge on mobile everywhere. And I think this is sort of like the math of averages. Video is not 25% of all websites, but the websites that do have video is such a huge amount that it skews the average across 1 million websites to 25%. But just like mobile websites and mobile apps, people get really, really mad when video doesn't work properly, whether it's on the desktop or on the mobile phone. My family's at home and here in Bucharest watching the Olympics, and it'll stop streaming. And it always does it like right when the ice skater is about to do like a quad or something, right? And it freezes. And when you deal a lot with mobile performance and video performance, they look at me. Can you fix that, Dad? No, I can't. I need to talk to the streaming company that's doing it. But you know, when you're the expert on these things, they come to you. It's like, yeah, the video isn't working right. And then, of course, we all know that when people are mad, they throw their phones, and that's why the picture of the phone. But what happens? What makes people angry? And so basically, this is a study from Akamai, and they found that after 2 seconds, nobody really cares. 2 seconds of video startup delay. So you start the video. If it takes less than 2 seconds, nobody really cares. But after 2 seconds, you lose about 6% every second afterwards. And so you start losing customers really, really quickly. Now, the other thing to think about here is all videos are not the same. There are different types of videos that people consume on the internet. You have the cat dressed up in a shark costume riding a Roomba chasing a duck sort of videos. And then you have movies, right? And so When it is sort of one of these nonsensical videos that your friends share with you, you click, and then after about 2 seconds, you start questioning your life choices. Like, did I really just wait 5 seconds to watch a cat dressed up like a shark on a Roomba chasing a duck, right? And you hit back, and you're like, I'm just going to forget that I ever did that, right? So people give up on short clips like that a lot faster. But if you're going to sit down and watch a 2-hour-long movie or a 1-hour-long movie, you're more likely to sit and wait 20 or 30 seconds for it to start playing. But you're still not that patient, right? You still lose 20% after about 10 seconds. So what leads to startup delay? And so this is HLS, which is the most popular streaming method right now. And the first thing that happens is a manifest is delivered. And that manifest tells you the different quality streams. So they have different bit rates, different dimensions of the video, and it tries to decide which is the appropriate one for your network, your device, the screen size, all of those different things. The player on the device chooses a stream, and it asks for a second file that lists all the video segments. All of that list of video segments comes, the player starts downloading each of these segments into a buffer. And as these segments are downloaded, it can begin playing. And so the buffer is this little line, and it's red in YouTube, right? It's how much is loaded on your phone. And as long as this stays ahead of the dot, the video is going to keep playing. But if it doesn't, then it's going to stall. So in this case, I'm going to say the video plays. But let's look at a trace that I studied with Video Optimizer. And this is the first manifest file. And so you can see there's 8 different streams, 8.5 megabits, 200, 400 kilobits per second, 600 kilobits per second, 1.2, 3.5, right? Different resolutions. How does the player pick which stream to start with? And it's kind of stupid, but we always pick the first one. So we picked the first one on the list, and in this case, it's 8.5 megabits per second, which, as you might imagine, might be hard on some mobile connections to start up really, really quickly. Even on 4G, that's a lot of data if you need 5 or 6 seconds to download before it starts playing. That can lead to a lot of delays. So what happens? The player selects that 8.5 megabit stream, and the buffer's taking a really, really long time to fill, and the video doesn't play. So what the player does is says, I need a different bit rate, and it just drops really, really low to a low quality so the thing will play. Because the player is programmed to know that it needs to start up quickly, so it's going to go to a lower quality version so it can start up quickly. And we can actually see this. We can see the list of all the files. We have that first manifest file, second manifest file. It tries the 1080p video and immediately drops down to 600 and downloads segment 0, 1, 2, 3. And then it decides, oh, well, the network might actually be good enough for this high one, and it takes 3, 4, 5, 6, 7, and continues, and it shows the whole video. In this case, I was testing on a really, really fast Wi-Fi connection, but even the player's like, 8.5 megabits per second is way too fast for this video to start up. And so the player knew this, and what actually happens a lot in what I see in these applications is most people sort of pick a middle of the road bandwidth to start with. The quality may not be super great, but it starts up quickly. And we all know that if it doesn't start up quickly, you're going to lose your customers. And you may see this sometimes when you're watching a video, like the first 5 seconds, the quality kind of sucks, but then it pops into something that looks really, really good. They do that because they want it to start playing so that you're happy, right? They want you to get that positive feedback, and then they make it even better. You're like, oh, it's even better, this is awesome. And so they play to that sort of idea. And so I often see something middle of the road, something like 1.2 megabit per second to be the first resolution. And obviously that's because you want to balance the startup time and the quality. And so here's a video that's going to play just fine, right? Because you can see as it progresses, the whole thing loads into the buffer before the little dot can get across there. But we do see videos where it starts downloading, and then the video player is slower than the playbacks and the video stalls. And I've seen this on my phone, right? I'm sure you guys have seen this too. And then the buffer starts filling up. You're like, oh, great, it's going to start playing soon, but it doesn't actually start playing. And the reason is the player knows I'm not loading up the buffer fast enough for the video to continue playing. And so you're sitting there like, but there's video, I want to watch it, I want to watch it. And you can actually hit pause and play, and it'll play like the next 1.5 seconds, and it'll stall again. You're like, oh. I do that. I see some nods, so I think other people do that too. We're really impatient when it comes to these sorts of things. So what the player's trying to do is balance, obviously, how fast stuff is being delivered to, how quickly it can play back and if the video can play back. And it's important to balance. And so, Cloudinary is a tool I mentioned. You can actually upload your video and it will build out all of those different resolutions for you in their cloud and then deliver the video for you. So you don't have to think about all this, you don't have to do all the encoding. Like, there are a bunch of tools that'll do that for you. It's just a cool way to do this. So you don't have to think about all the different bandwidths that you want to do. And then I'm going to rip on this one video a little bit longer. I'm going to graph these bandwidths so you can see them just in a different way. And what you can see is the lower quality bandwidths are kind of like here. And it's a nice gradual growth. And then at high quality, there's a faster growth. But there's like a jump right here in the middle. And unfortunately, that jump screws up the video streaming for this video. And I'm going to walk through why that is. And it leads to streaming issues. And so what happens is, this is another version of the stream. So it starts at 1080, drops this 360p, 600 kilobits per second. And so, that's my PowerPoint rendering of it dropping to low quality. And then the player's like, I can go a little faster. So it goes up to 3.5 megabits per second. Quality gets better. The customer's like, yeah, better quality is great. But that's still a little fast. So then the player drops down to 1.2 and then back to 3.5 and then back down to 1.2. And you sort of get this ping pong effect. I got one more. All right, yeah, all right. And so the video keeps bouncing back and forth here. And what can happen is, just like I said at the beginning, where you see the quality get good, every couple seconds the quality's getting good, it's getting bad, it's getting good, it's getting bad. And that can be distracting to your customers. The other interesting thing to look at is look at segment 4. It's downloaded at 3.5 megabits per second, but then when the quality drops down, it's downloaded again at 1.2. Well, which one plays? Is it the really good quality one, or is it the bad quality one? Why was the second one downloaded? I don't know, the player got confused. We can actually see 5 and 6 are downloaded twice at 1.2 megabits per second. So this is just 3.6 megabytes of extra data that your server just delivered to the customer. So if your customer's not on an unlimited data plan, and then of course, if you're paying for all the data coming out of your servers, this is just added expense. So you should look at these sorts of things to see if you can prevent that from happening. And so again, those jumps in quality can be visible to your end users, and we should try to avoid that. And that's just that list again. I don't know why that slide is there. All right. So in conclusion, and I thank you guys all for listening so intently to me, but we talked a little about delivering with a CDN, so all of your content is at the edge of the network, reducing the number of redirects so that the content's delivered quickly, and then basically make everything smaller. The smaller the files are, the faster they're delivered, the faster they show up on the screen, and the happier your customers are. It's pretty basic stuff, but the number of apps out there, the number of websites that still have room for improvement on this, is pretty impressive. And so here are a bunch of the tools that I talked about. Web page test and website speed test. Video Optimizer is a tool I worked on for many years at AT&T, and there's some screenshots in there. This is the book I wrote, and that is the PDF if you're interested. I wrote it when Marshmallow came out, so it's a little old, but most of it still holds. And then finally, I talked a little bit about some of the cool stuff that Cloudinary does. And then finally, I was showing some of the stuff to Cloudinary to make sure that I was using their processes right. And they said, hey, we'd like to sponsor a contest for GDG Bucharest. And so the Alexa 500 is a list of all the top websites out there. And so run them through, pick a couple of them, run through webspeedtest.cloudinary.com, and then tweet the result URL. Find one that has a huge amount of savings. Because there are a lot of web pages out there that still have a lot of room for improvement to make these faster. And then tweet it, or if you don't do Twitter, you can email me at highperformanceandroid@gmail.com. And whoever finds the biggest savings is going to get like a set of headphones or something from Cloudinary. And so that's kind of cool. And hopefully some of you will do it. And I'll just show you what it looks like in website speed test. And I actually loaded this page before I got here, so it's already here. And there. All right. So I tested my former employer's website. And what you see here is that there is about 29% potential savings in just resizing the images on, you know, AT&T is a big company, right? You'd imagine that their website would be optimized, but it isn't. There's a lot of room for growth on these web pages. So what you could do is just, it's not showing up on the screen, but, you know, tweet this URL right here out to with the hashtags Cloud Mary, GDG Bucharest, and, you know, if you have the biggest savings, you win a prize. So that's kind of cool.
So the goal is to create a site that has
The most room for improvement. Exactly. And so and what's kind of mind blowing about that is you see these web pages that everybody uses every day, and you're like, wow, you know, if 100 milliseconds means 1% more revenue, what could all of these websites be doing, in terms of their performance? And so with that, I'd like to thank you all for listening, and happy to take any questions.
Great presentation, Doug. I would have a first question.
Yeah, you bet.
Are you familiar if there are any adaptations of the HTTP protocol to handle this sort of situation? I imagine like adding some headers to include things like the network speed, or
Yes.
could let you pre-select some of the, say, have some presets on, let's say, video.
I believe Chrome has a network speed header, and it just measures the packets coming in and out, and it says you may not be on 3G, but it calls it a 3G network based on the speed, or a 4G network, or a fast. Like, it breaks it down to a couple different categories. So Chrome, I believe, does that. Yeah, and there are actually a bunch of monitoring tools that you can put onto your website that will tell you how fast the page is, and so you can dynamically make those changes. And sometimes you can just do things by knowing that it's a phone versus a desktop. So there is work in that area, but unfortunately, if it's just Chrome, that's still only 40 or 60 or whatever % of your users actually use Chrome. Yeah.
Most of your optimizations there are on the backend side.
Mm-hmm.
Do you have any optimizations on the client side, on the mobile application? In my case,
You're on the front end, yeah. My book has a lot of stuff on layouts and like improving. It's kind of sort of the basic stuff on Android. Like, the more paints you do on the screen, the more you can set the overlay on your Android phone, and your screen turns red when you have too many overlays. I've seen that cause massive delays on apps. Let me think. I'll think about that and I'll come back to it. But yeah, most of the stuff is actually on the back end to improve the front end performance of your app. That's true.
Thank you very much, Doug.
Awesome. Thank you, everybody.
So, we'll get to ask more questions in private in the networking session. Excellent. So we'll have a quick break right after. So before the break, I want to